In today's lesson, we are going to be looking at some specific word problems focusing on mixing different volumes. We've looked at some word problems in elimination and substitution. Now we're going to focus on a couple types of scenarios that we might come across, just because they are a little bit different, or it might be a little bit harder to come up with the equations. So we're going to look at one in this lesson. We'll look at another one in the next lesson. And again, like I said, today is focusing on mixing different volumes. So in our first example, Miss Curie has a bottle of 5% acid and a bottle of 10% acid. How much of each should she use to make 250 milliliters of 8% acid? Right, so it's a little bit of a trickier question of how do we set this up? Right, coming up with our two equations, which we know we need to do. First thing we need to do, similar to our other word problems, is write out what our variables are equal to. So we do have two variables. We're going to let x equal the volume of 5% acid, or how much 5% acid we use. And we're going to let y equal the volume of 10% acid. So how much of that did we use? Similar to our other word problems, once we have our two variables, now we need to come up with our equations. And the equations are going to be the trickier part of these types of questions. We're going to go through in steps to help us kind of figure that out. So we're going to need to come up with two equations. The first one is going to be fairly straightforward. It's going to be the volume of the first variable plus the volume of the second variable equal to the total final volume. So basically we know how much acid we need to make, and we know that we have two different types of acid. So the first equation is just going to be looking at the volumes. We have our two variables x and y representing our unknown volumes. So all we're going to do is say x plus y equals 250. So x plus y equals 250. That's going to be our first equation. So just the two unknown volumes adding up to our total. Next, we're going to create an equation that focuses on the percentage. Right? So this is going to follow as the percent of the first variable times the volume of that variable. So we already had that laid out, right? We had 5% acid as our first one. So 5%, keeping in mind percent, we'll write here, 5% equals 0.05. So we're going to use decimals in these cases. So 5%. So 5% times the volume of that variable. Now we don't know what the volume is, but we did let x equal that unknown volume. So 0.05x plus the percent of the second variable, or 0.10, because 10% is equal to 0.10, and this percent of the second variable, or the second type, multiplied by the volume, which we had already set to y, and it's going to equal the percent of what we're making times the volume that we're making. In this case, it's going to be 0.08 multiplied by 250, which is just coming from the second, or the last bit. So 250 milliliters of 8% acid is what we're trying to get. 8% as a decimal is 0.08. So now I have my two equations. The next step now is we're going to solve by substitution or elimination. So I'm going to write out my two equations again. We had x plus y equals 250. This will be equation 1. And then we had 0.05 x plus 0.10y equals 250 times, or keeping it, it's consistent with percent first, 0.08 times 250. And that's our second equation. So now we have to think about, okay, which are we going to solve by substitution or elimination? These numbers are a little bit too off to really use solving by graphing unless we're using a graphing calculator or graphing software. But if we're using algebra, in these types of scenarios, we can use substitution or elimination. It doesn't really matter. We should still get the same answer. So we're just going to use use the method that you prefer. Now, we did mention when we looked at substitution and elimination that there are scenarios that are better suited for each one. So there would be better options or better methods, or a better method to choose from. But again, both of them work. Now, the best method I would suggest in this one is substitution. So the reason I'm saying substitution is because if I look at the x and the y in the first equation, they are both, or they both have 1 as a coefficient, right? So that makes it really easy to rearrange, right? So I'm going to rearrange equation 1. So I'm going to rearrange equation 1 for, and again, because both variables have a 1 in front, it doesn't really matter, but I'm going to rearrange for x. So I'm going to do x plus y equals 250, move the y over, x is equal to 250 minus y. Good, I've rearranged. Now what I can do is I can sub x equals 250 minus y into the second equation, into equation 2. So I have 0.05x plus 0.10y equals, and I can we'll worry about that later, but 0.08 times 250. I'm going to substitute it in, so 0.05 times 250 minus y plus 0.10y is equal to, and I can actually simplify this part over here, so 0.08 times 250 is 20. Now I'm going to solve by distributing the property. So multiplying the 0.05 through, we have 12.5 minus 0.05y plus 0.10y equals 20. I'm going to solve by, we're going to collect like terms and solve, or try to solve. So negative 0.05 plus 0.1 is 0.05y. I'm going to move that 12.5 over, so it becomes 20 minus 12.5. 0.05y is now equal to 7.5. And last step is to divide both sides. One side will cancel out. We're left with y is equal to 150. So now that I've solved for y, I know part of my answer, right? So I can say, therefore, she needs 150 milliliters of, and y represented, if we go all the way back, y represented the volume of 10% acid. So she needs 150 milliliters of 10%. And now we're going to fill out the rest, right? We're going to find the other value. So the other value, we take that y value that we found and we plug it into an equation. Now we already have rearranged equation 1, or I can just look at equation 1, x plus y. Let me just write what we're doing. Sub y equals 150 into, and I'm going to use equation 1 just because it is easier, but again, you could plug it into either one. So x plus y equals 250. X plus 150 equals 250. Simple one-step equation. X equals 100. So therefore, she needs 150 milliliters of 10%, and 100 milliliters of 5%. So again, the steps for solving the substitution and the elimination, again, depending on what we do, is going to be the same as what we've looked at before. The only difference in these types of questions comes from setting up the equations. But we kind of have a standard format that we can use when we're dealing with percent questions. So let's look at the next one. Example 2. Milk and cream contain different percents of butterfat. How much percent milk, or how much 3% milk needs to be mixed with how much 15% cream to give 200 or to give 20 liters of 6%. Right, so this might be something if you're into food sciences or you're into manufacturing, or you need to mix these ingredients to kind of get a new type of, or a new percentage of cream or milk or half and half or whatever it may be. You might need to look at these types of calculations. So first things first, we want to write out our variables. So if we write out our variables, right, similar to the last step, so let's focus on what we have. We have two different percentages, 3% and 15%, and we know what we want, 20 liters of 6%. So our first equation is going to be focused on, or write out what our variables equal. We're going to say let x is going to equal the amount of 3%, and y is going to equal the amount of 15%. Next, we're going to write out our equations. So if we go back to those steps, our first equation is going to be just looking at the two volumes. So we're going to have x, which is one volume, plus y, which is another, adding up to 20 liters. So that's going to be equation 1. The next is going to look at the percentages, or include the percentages. So we're going to have the percent of x, so 0.03 multiplied by x, don't need the brackets, 0.03x plus 0.15y is equal to 0.06 times 20. And that's equation 2. Now that I have these two equations, right, now I can go through and solve by substitution or elimination. Now again, in this one, I'm going to use substitution just because it is a little bit easier based on the values that we have. Or actually, no, let's go through and solve by elimination so you can see it done both ways. Right. Again, I would suggest that this one be done by substitution just because it does lend itself to be done in that method with the variables in front of x and y in equation 1 working out to be just 1. But let's go through elimination so we have at least two examples. Right, so if I want to eliminate, I need to get the variables the same, but right now they are not. However, because the variables in front of x and y are both 1, I can multiply equation 1 by anything or by something and get either the x's the same or the y's. I'm going to get the x's the same, so I'm going to multiply equation 1 by 0.03. And that will give me 0.03x 0.03y is equal to 0.6. I'm going to have equation 2, so 0.03 x plus 0.15y is equal to 0.06 times 20. I'm going to simplify that first, which is 1.2. Now, if I look at this, the values in front of x are the same. So now I need to think about, do I add or subtract these two equations? Well, the signs in front of the x's are the same, so I'm going to subtract. The reason I do that is because 0.03x minus 0.03 is 0. Again, I mentioned maybe put brackets around the bottom equation just so that it helps us remember that we have to subtract everything. So 0.03 minus 0.15 is negative 0.12y. And this is going to equal 0.6 minus 1.2, which is negative 0.6. Now I want to solve for y. So negative 0.12y is equal to negative 0.6. I'm going to get y by itself by dividing both sides by negative 0.12. One side is going to cancel out. And when we divide, we get that y is equal to 5. So that tells me how much of chemical Y, or not what chemical, the cream, which was the 15%. So I know a little bit. I know therefore 5 liters of 13% cream is needed. And now we need to figure out the other part. So I'm going to take Y and I'm going to substitute it in. So sub Y equals 5 into equation, let's say equation 1, right? The x plus y equals 20. So x plus y equals 20. We know y is 5, so x plus 5 equals 20. One-step equation, x equals 15. So therefore, 5 liters of 13% cream is needed and 15 liters of 3% milk. So again, 2 different examples of mixture questions done both by elimination and by substitution. Again, either method is fine for you depending on what you prefer. I would suggest that these types of questions, at least so far, the ones that we've seen, do lend themselves nicely to substitution. But as we just saw, we can solve by elimination as well. So again, whichever method you choose is fine as long as you're comfortable with it and as long as you can follow the steps properly to come up with a solution. I would say, at least for coming up with the equations, make sure you practice that. Make sure you kind of think or revisit the steps that we saw in our notes for how, or the guide, so to speak, to creating those 2 equations. Because once you have those 2 equations, it's just elimination or substitution, which we've practiced already.